Hello everyone, welcome to Amazon Web Services Machine Learning Operations with AWS Masterclass, and we are in day 20 of this Machine Learning Operations with AWS. And in the previous class we have discussed about the base things of deep learning, like what are the conceptual wise what you need to know and other things, etc. And today in this class we'll learn how to build it using TensorFlow Keras by building a project. And one step going forward, we are going to build a CNN today, a convolutional neural network, and we want to understand. Okay, so let me give you a glimpse of how a CNN works, how an image is processed in a CNN, and let us understand that features also. And then finally, we can go and take. Today, we'll be seeing another project, which is fourth project, which is dog versus cat identification using a CNN network. We'll learn how to do it, and we'll test it also in the later part. Okay. So let's start with the class convolutional neural network. Okay, we have learned about neural network. So what is a neural network? Once again, collection of neurons. So in an artificial neural network or a typical neural network, we have an input layer where the inputs will be passed, and it will do the process by adding bias and weight, doing activation function, giving the output to the next layer where we will be having multiple hidden layers. It will do the process and give it to the output layer where the loss function is calculated. So based on the loss, optimizer will add or readjust the weight and bias so that this will go into backpropagation to update it through backpropagation. And then what it will do, it will come back once again, and this process will go once, like both the side, to improve it. Okay. And going for convolution neural network, this is an optional one for image. So what you can see is we are having an image and we are passing the image input, and it is processed in such a way that it can be processed into base numerical format, which can be given to again an input neural network, and then it will do the same process. That's what the idea behind this CNN is. So a CNN use a unique architecture with convolutional layers that allow them to learn local pattern and features from the input data, and pooling layers that reduce the spatial dimensionality. We'll be discussing the meaning of them. So this makes CNNs well suited for tasks like image recognition, object detection, image segmentation, etc. So in this case, this will succeed. CNN has a major role playing in it. And this is what a CNN will look like. So when you go for CNN, convolutional neural network, before going into the layers, okay, the fully connected layers, this is what your input layer, which means you have an image, you are doing many processes here, and then you are going and giving it to the fully connected layer, which is going for output layer. So we are having this. So what is this convolution layer? What is happening here? We have ReLU, we have pooling, we have flatten. What it is, we'll learn it today. Before going into that, you want to know or learn about the base of the image processing. Like for example, when you have a black and white image which has color channels, which is only one, the number of channels of color is 1, and it ranges from 0 to 255. If the value is 0, which means it's a black image, and if the value is 255, it is a white image. They are just numbers, the pixel value I am telling. And when you go for a RGB image, red, green and blue image, here the channel is 3, which means it's a 3 channel one. It has a red channel, it has a blue channel, it has a green channel, and they also range from 0 to 255. But how much they are differing, that will determine the output color. For example, you are having a color where the red is 255, green is 0, blue is also 0, means the output your output will be red. So likewise, the image color is determined based on the values of 3 channels. Okay, so now you have the numerical format. When you take an image, they have pixels, and this pixel is nothing but numbers ranging from 0 to 255. And if it's a black and white image, it's 1 pixel. And if it's a RGB image, you have 3 channels. Here 1 channel, here 3 channel combined together to produce the same color output. So now what you can do is, even though you have an image, you can segregate it into pixels, and you can get numbers of it. Okay, you can turn it into an array, you can get all the numbers in your image, which you are going to do some processing and give it again to the neural network, where with numbers they can play, right? With numbers they'll go and do the processing. They'll calculate the loss, come back and do all the same steps here also. And this is what one convolution operation will look like. So now our focus is going to turn on this part. Okay, we know what will happen here. We have learned it in the previous class. We know what is happening here. But when you go for this image task, you want to learn what is happening in this part. Okay, what is happening in this part, which is convolution operation. So a convolution layer, what is happening? So we are having our input. You see here, this is an image, and it is a 6 cross 6 cross 3. The matrix is 6 cross 3 matrix, but it's a 3 channel. So we have 6 cross 3 clubbed together. Okay, and then some filter has been passed and something has been doing, and then it is going for ReLU function. So here also some activation is happening. What will happen in ReLU? Only the positive values are taken, right? The maximum between the 0 and the given value is taken. So if the given value is positive, it's going to be there. If it's negative, 0 will be there, right? And some output is obtained. So our task is to separate this and understand what is happening there. First, we want to learn about what is a filter. Okay, when you have an image, the first step you are passing it to a filter. So we are adding some filter. So what is happening in this filter? Imagine, now focus on one matrix. You are having a 6 cross 6 matrix. Can you see here? This is the input you are having. So this is an image where it has a 6 cross 6 matrix with numbers, and you are having the numbers here. And what will happen is, a part of it is taken. For example, in this 6 cross 3, first this 3 cross 3 will be taken as the image patch. So a part of that image patch is taken. And along with that, a filter is passed. So this filter you will be passing 3 cross 3 or 4 cross 4 according to your requirement. And imagine this is the kernel. So this number you are not going to fit. This number is updated via backpropagation by the CNN. So you don't want to worry about it. But a filter is passing. You can add filter. So what this kernel will do it. This is the 3 cross 3, this is the 3 cross 3, it will do dot operation. Okay, a filter is used to extract features from the image. So what will happen is, a kernel is a submatrix that moves from the input data and performs dot product with the subregion of the input data and gets the output as a matrix of dot product. So here the dot product is done and the value is stored here. Okay, then what will happen? How this value is filled? This kernel, it will move to the next 3. Okay, it will move one step, it will take the next 3, and kernel, the same kernel is added and the value is stored here. Likewise, it will fill. Okay, see here, this highlighted portion is taken and the filter is added and the output is stored here. Likewise, it will till the last one, it is done, and some important information alone is taken from this entire thing. Okay, so this is what will happen. See here, this is also a representation of it. So you are having this input image where a patch is taken, this, okay, along with that a filter is added and the value is stored in that respective place. Okay, and you want to also learn about stride. So this stride, it's simple. What is the stride value is, if you set the stride value is 1, which means when the kernel chooses this patch, if the stride value is 1, for the next patch it will move one step, and this is the next patch. Okay, if the stride value is 2, which means if this is the first patch, then the second patch it will move 2 steps and then take this patch. Got it? This green one, how it is differentiating here, 1 step, here 2 step, the next. That's what happening. The filter, how much it is moving, it is called as strides. Remember the term stride, how much the kernel is moving and taking the patch. Stride 1 and 2 are commonly used. Okay, and then we want to discuss something known as padding. So what is this padding? Before going into padding, can you see the difference here? I am having a 6 cross 6 matrix, okay, adding a 3 cross 3 kernel filter, and my output is 4 cross 4 matrix. Am I correct? So my thing, the image and the matrix size or the information is keep on decreasing. I want to extract important information, but I don't want to lose things. Okay, I don't want it to reduce in size. So here we are actually losing some information. Our 6 cross is turning into 4 cross 4. When you go furthermore, it will keep on decreasing. To avoid that, we are adding something known as padding. So padding or pad adding, these are nothing but adding extra layers. Okay, to increase the size of the output and save the information presented in the corners. Okay, we can use padding layers, where padding helps by adding extra rows and columns on the outer dimension of the image. So in the outer dimension, it will add something like 0. So if we have 0 padding or same padding, so same numbers will be replaced there with 0 padding everywhere, it will be 0. But the thing is, what this 0 will do is, now when the value, like first kernel is taking, it will take this one, okay? And what will happen now, this 6 cross is turned into 8 cross 8, and if it passes through 3 cross 3 matrix, and the output you are getting is 6 cross 6. So your original 6 cross 6, the output is also going to be 6 cross 6, and the information can be remain similar, okay? The size of input can remain similar. So that's what we are adding. Padding is extra layers. And the padding, when you compare, we have 1 padding, 2 padding, etc. So to avoid losing information, you can increase it also by adding 2 layers. We have something like 0 padding, where 0 is added, same padding, same numbers are added, etc. So I hope this kernel, okay, these 3 terms, let us see a recap. So when you go and see this convolution operation, you are having your input, a filter is added, and you are getting output, right? And what is this filter is doing? It is going to take the patch and do dot operation and store the output. Okay, one output is got. If I want to move to the next one, if it moves to next one, okay, one step, it is called stride 1. If it move 2 step and take this box, it is called stride 2. Okay, that's what the stride is. And again, here we are losing information because the corners have been lost. This is a 6 cross 6 matrix. When you perform operation with 3 cross 3 matrix, your output is going to be 4 cross 4. You are losing information. So what you are going to do is, you are going to add padding layer, which is extra layer added, okay? And these are dummy layers which will help you to, like for example, now our matrix is 8 cross 8 multiplied with 3 cross 3. Your output is your parent 6 cross 6. So your original 6 cross 6 and this 6 cross 6 is going to match, okay? Yeah, that's it with this convolution input and filters. Finally, you are going with ReLU function, okay, activation function. And for example, this is your input you are getting, okay? Finally, after this process, you are having this. What will happen if you pass it to ReLU? See here, ReLU, what it will do, we have discussed this in yesterday's class. What will ReLU do? ReLU will take a maximum value between 0 and the given value, right? So you are having a given value, and it will take the maximum value between 0 and the given value. So for 0, here the negative values will be given as 0 because 0 is the biggest one compared with the negative one. So only the positive values has been taken out from whatever you have processed, okay? And this is what ReLU will do. It will take all the positive values and the negative values will turn into 0, and then it is going like bias is added and the output is given, okay? So this is what in a base convolution layer, it will be calling it as Con2D, convolution 2D layer. This is entirely will happen in that one single layer. And then, okay, we cannot, okay, well, let me go and tell you the image where we have, yeah. So the input, I am passing through the convolution layer plus ReLU. So what will happen? Filter is added, patch is taken, stride will be helpful for you to move, okay? To avoid losing information, you are adding padding, you do everything, you give the output, ReLU is done, and the information ReLU output is given. And when you can see, after this layer, we have something known as pooling layer, and then you can have multiple convolution layers, guys. So if I am passing it to another convolution layer, after convolution layer, I am having another pooling layer. So it seems like whenever I am going for convolution layer, I have to go with pooling layer. That's correct. Whenever you do the process with convolution layer with activation ReLU, you will be passing it to pooling layer, okay? Every time it is mandatory. So what is this pooling layer and what it is doing? So pooling layer, we have many types, and one common type is known as max pooling layer, okay? So whenever you are having a convolution layer, next thing is going to a max pooling layer, okay? It will be the same step. So what is the max pooling layer will do? It will take the maximum values. Here also you will be passing a filter and a stride value. For example, if you have 2 cross 2, okay, so it will split it into 2 cross 2 matrices, and from this 2 crosses, which is the biggest one, 9, right? That 9 is chosen. From this, which is the biggest one, 7, that is chosen. From this, which is the biggest one, 8, that is chosen. From this, 6 is the biggest one, 6 is chosen. You can set the filter size of the max pooling layer. It will split them and take the maximum values alone from that layer and pass it to the next step, okay? And what will happen when you have a convolution layer? It will do ReLU, and that output, the max pooling layer, it will do the process and give it to the next convolution layer. There once again the same step will happen, and from that output, max pooling layer will pick up the maximum information. Likewise, you can have multiple convolution layer, and if you are done with that, you can give it to the neural network, which we have discussed in previous class. But before that, there is only one step pending, last step, okay, which is called as flattening layer. Okay, the final step for you is to go to a flattening layer before going into a fully connected neural network. What is this flattening layer? Like, see here, we are having image, convolution plus ReLU, pooling is done, convolution plus ReLU, pooling is done, convolution plus ReLU, pooling is done. Before going into the connected layer, I need to flatten it in a way that it can be passed as individual information to the neurons of the input layer. I want to make it in a single way that it can be splitted and given to the next neurons. Okay, so what this flattening will do, if you remember this guys, whenever you go for a convolution layer, you should have a max pooling layer after that. And once you want to, you can have multiple this max pooling and convolution 2D combo. But once you are done with that, if you want to go and give it to the next layer, okay, which is the fully interconnected layer, you must go through it through flattening. And what will flattening will do is, for example, if I have 1 1 0, it is just elongating it, okay, and 4 2 2 is elongated in this way, 0 2 1 in this way. Now all the layers, okay, all the values are flattened into a single part, okay, and this flattened input you are having, right, this is passed after flattened layer, it will be passed to the neurons, and this neurons will take it and do its job. It will go and get output, okay, compare it, coming for back propagation, verifying it, going back again. The same step will happen here also. Fine. So this is what the base you want to know before going into this kind of project with CNN. And we haven't created a neural network till now. Let us create it hands-on by seeing this project. So we are going to see the fourth project in this AWS masterclass on machine learning operations. And the project we are going to see now is dog or cat identification using CNN. So the introduction of this project is, the objective of this project is to write an algorithm to classify whether the image contain either a dog or a cat or both. Okay, so if you are creating a algorithm where if you give an image of a dog, it should tell me it is a dog. If it is a cat, it should tell me predicting it as a cat exactly. How it can be done? So we want to collect and pre-process a labeled data set of dog and cat. So we need to have a lot of dog images and lot of cat images for training the CNN model. Once we have this, we can build and train a CNN model and then connect it to a fully connected layer where it will learn appropriately. And finally, once it is trained, you can use it for the dog or cat identification project. So let us go hands-on and see about it. Let me open my console, and this is what the dog or cat identification project is, and I'm having my notebook instance opened. Okay, it's a notebook instance, and here, like in this itself, I'm having this dog versus cat file. Okay, so I'm having a zip file, basically this zip file, dog versus cat zip file. You can take it from Kaggle. So in Kaggle, you can get this dog or cat identification data set, which is images. Okay, I think nearly like 5,000 or 10,000 images for dog and for cat also. So you can download it as a zip file, and individually you cannot go and take an image, so you can store it in S3 or like this in the storage itself. And what you can do is to open it, you can import zip file, and if you don't have, you can install it too. And what the zip file will do is, from that you can read the zip file using R, which is for reading. Okay, once you read the zip file, you can call it to extract all and close it once you've done it, and this will extract it in the location where you are having your zip file. From that you can take it later on. First, like I already have this, I don't want to run it again. And for image opening and closing tasks, we may need OpenCV Python. So it is an elaborate thing separately. It is called a CV2 computer vision. Okay, it's a separate field or separate domain. For handling images, we will be using this using OpenCV-Python. And you need TensorFlow. Like remember TensorFlow, which is the library which we are going to use for creating the neural networks. So we can import TensorFlow. Okay, to first install it, and if you want, you can use this particular version 2.10.0, and you can go with other versions too. I have these things, and I can take like import TensorFlow as TF, front TensorFlow, import Keras. We have Keras separately also. We will be importing something known as sequential. Remember the sequential. This is like a base for your model or template for your model. With this sequential, you will be connecting the layers. When you call sequential, which means you are going to create a ANN or CNN with that. It is for creating the neural network to sequence it, okay? And then from keras.layers, we have dense layer, convolution 2D layer, max pooling 2D layer, and flatten layer. Remember, you know convolution 2D, this is the convolution layer. Max pooling is for max pooling layer, and flatten layer finally. What is this dense is? Dense is for creating hidden layers. Remember the neuron layers, hidden layers, okay? Those hidden layers and output layer or input layer, everything can be created with dense. And let me run this. Okay, it is. We will wait for it to complete. Let it done, let it import it. In the meantime, we'll see about the image generators. Okay, so from keras.utils, you can go and take image dataset from directory. So this has been done. So the required libraries has been imploded. Now it's time for us to load the dataset. So we have, okay, the training and testing dataset. If you go and import this zip file, you can find two different folders, train and test files, and in that you can find dog folder and cat folder to take the image. So from Keras, you can take this from the directory itself using utils image dataset from directory. So directory, it will take it directly. So directory I'm giving is train folder, and the label is given that, okay, and the batch size is 32, and the image size I'm going to set is 256, 256. Okay, the image size. And for validation, which is for testing, I can go and give like validation or testing, both are same. So we can give that directory as test, where you can take it in the integer mode, and let us keep the batch size at 32, and the image size I'm going to take is 256, 256. And let me run this. And this will give you some information like this. So it found 20,000 files belonging to two classes, which is nothing but dog and cat. Okay, 10,000 dog image and 10,000 cat image for training, and 5,000 cat image and 5,000 dog image for testing. So totally 25,000 dog images and 25,000 cat images are here. You can go and extract it and see it. Okay, for the internship users, I'll be giving it in the downloadables. Please make use of it. Others, if you want, you can go and search it in Kaggle and download it. Okay, and we have our data loaded in train underscore dataset and test underscore, validation underscore ds. And yeah, next step is we want to make a process thing. So before going, and this is where we are creating the neural network. This is how you will create a neural network. But before going into that, we have to do some base image processing, and we are not going any complex. But when you go for OpenCV kind of task, you may do some kind of critical things. We want to learn about OpenCV to learn about the pre-processing of an image. But here we are doing it simply. And when we go with this Sagemaker environment, that TensorFlow is having some error, which means usually the image channel will be in this way. Okay, 256, 256, 3, which means 256 and 256 are the matrix or the pixel information, the 3 will be the channel. But here the TensorFlow expects you to go with channels last. Okay, sorry, it's channels first. It should be in the first place. 3, 256, 256. It should be in this format. It is expecting. So, but our images in the channel should be in the last, but I want to store it in the first. So I want to do some processing. So, but when you go and call this train.ds and validation.ds, it has both the image and the labels for it, like dog or cat. You can go and call or create a function by getting both of this. So if I pass this, it will get the same, both. And first I'm resizing it in a way that first the channel and then 256, 256. Okay, the image will be reshaped, and it will be like from the negative way, which means 256, 256, 3 will be now turned into 3, 256, 256. And we want to do something known as transpose. Okay, it will change the transposition of this. And finally we have processed image. Okay, here what I'm doing is Imagine you are having like values which are from 256 0 to 256, and these are numbers, these are heavy. Okay, if you want to scale it, okay, instead of going with normalization, what will happen in normalization? Tell me, guys. The values will range from 0 to 1, right? In machine learning, we have done, right, the data. It will range from 0 to 1. Similarly, here for normalization, what you can do is your maximum value is 255. Okay, 256, 255. That's what your maximum value in that image is going to be. Okay, so what you can do is every number, if you divide it by 255, then the minimum value you can get is 0 and the maximum value you can get is 1, right? So that's what we'll be doing. If you divide it by 255, your all values will be converted into a range between 0 to 1, and I'll turn it into float 32. And finally, label is not touched, only the image has been processed. Okay, I can use from this. Okay, this is from Keras, so I can use this map and pass this function. So this image and label will be processed. Label will be same and image will be a processed image, and again it is storing in train underscore ds and validation underscore ds. So this is one of the base of image processing for this task, and this has been completed. Now this is for training and this is for testing. Okay, so now it's time for us to build a neural network. So we are going to build a base neural network. See here, from TensorFlow I'm importing Keras. Okay, and Keras.layers, we have already done it. Okay, for safety you can do it also once again. And what I'm going to do is, this is where I'm going to create my model. Okay, model equal to, this is where the neural network is created. I'm calling Keras.sequential. Remember that sequential which we have imported. As I told you earlier, sequential is for creating sequence of neural networks. First layer, I'm going to create a convolution 2D layer. So this is going to be an input layer where you want to mention the input shape also. So this will contain 32 neurons. Okay, you can go with 32, 64, 128. These are commons. Okay, and input layer 32 neuron. Then the first number you are mentioning is 32. This convolution 2D is from here. You are importing it and directly using it. In this sequential, you want to create inside a square bracket. Okay, comma, kernel size is, I'll go with 3 cross 3 matrix. This is the size for the kernel. And the activation function, I'll go with ReLU. And the input shape is 3, 256, 253 as required here. And then the padding is same here. You can go with 0 padding or same. And next, once we go through a max convolution 2D layer, next we have to go through a max pooling, right? Max pooling 2D, which I have imported from here. And the pool size is 2 cross 2. And the padding here also same. And then again, convolution 2D layer with 64 neurons, max pooling layer. Once you give input, only in the input layer you want to pass the input shape. Other than that, you don't want to pass anything here. But here it is important. If you change it, you won't be getting proper output. Okay, and then you can go with another convolution 2D with 64 and another max pooling. So once I'm done, I can go and call this flatten layer. So what this guy will do, it will elongate and convert everything into flattened layer. And then I'm creating a dense layer. You can have multiple layers. Here I'm just adding one hidden layer. You can have like this. If you call dense, it will create another layer. And this layer is having 128 neurons. All will do ReLU activation and give you the output. Come on. The final dense layer you are adding is like, it will automatically recognize that is the output layer. So whatever the final dense layer you are adding, if you want one output, here the class is 2 binary classification, right? It should be 1 because your output is going to be 1 and you will be getting one output. And activation is sigmoid because it's a binary classification. Remember when we discussed in previous class regarding whichever the activation I should use, whichever the ReLU, okay, activation in the hidden layer and in the output layer, I need sigmoid because this is a binary classification problem, dog or cat. Okay, so once you create all these things, you can go and run this. Okay, and what you can get is, you can go and ask for summary, and this will give you the name of it, what is the parameter of each, how much it is passing. Okay, and all these things will be given. And once you are done that, before going into fitting is like training, but we want to add something details known as compiling. And in compiling, you will be adding the name of the optimizer you are using, loss and metrics. Okay, optimizer, as I told you earlier, we have two. One is gradient descent, another one is Adam. And now Adam is best. You can go with Adam optimizer. I'll choose Adam. So in compile, before going into that, you have to compile it. You have to mention the optimizer and the loss. For binary classification, what is the loss, guys? It is binary cross entropy. And then finally the metrics, it is accuracy calculation because it's a binary one. And I'll go and set this to, and now it's time for you to go and train the model. You can go and create a variable for it in history and then call it. I'll be passing the train data and I'll tell you what a epoch is and the validation data for validation. Okay, now the training and testing is passing. It has the labels. Now it should train. I need to pass something known as epoches. What is this epoch? You'll be having some numbers like this. If you set 10 epoch, it will run 10 times. Okay, one epoch means all the data points will pass through the CNN, okay, and give the output. That's what known as one time epoch. It will do back propagation and come back. Okay, it is one epoch. So the number of epoch increases, the number of training increases. Okay, if I set 10, it will train 10 times. All the data points from one end to other end and coming back. If I set 100, it will increase. 100 times it will run. It may improve, every time it may improve, but you cannot go with like many numbers. Like if I go like 1000, will it go and keep on increasing? No. After some point it will stop, the like improvement will be stopped and overfitting will happen. Okay, to avoid that you can go with optimal number based on the requirement. So I can run this once. It is going to take some time here because we are using the base instance MLT3 medium. It doesn't have GPU option, so we'll be going with the base CPU, which will take lot of time. So we'll run this, okay, and you can see how the epoch is running. So the epoch 10, the first epoch is starting. And what will happen is this epoch will split them into batches. Okay, we have a lot of points, right? We cannot pass it entirely through at once. Okay, see here, it has been splitted our points into 625 batches. Okay, all your input is splitted into batches, and one by batch will be going through, pass through this. So all the points will cover one step. It is called as epoch, and you can see the loss and accuracy. Once this 10 is completed, if you get some good 90% accurate, you can go with that. Or else if you get any low, you can go and add some more epoches or some more layers so that it will keep on increasing. So what we'll do is we'll wait for this to complete. It is going to take some time. Please wait. Once it is completed, we can go and add some other image and test this. Okay. And now the epoches has been ran successfully. So we'll wait for it to wind up. And once it is done, what we are going to do is we are going to make a predictive system. Like for example, this will load and show you the image, and it will ask you the image path. So if you enter the path inside of it, it will do the base pre-processing which we have done for the training. Okay, so that pre-processing will be done and it will return you the output image. So if I run this, okay, so this process image, first I am going to read the image using CV2 to show you using PLT. And then I'll pass the path of the image which I'm having here. Okay, the image and image 2. So let us try to get the model to predict it and get the answer. And this is what it has been predicted, this as a dog. This is the output it is giving. So I have another image 2. So let us go and try with that too. So it is a cat image, and you can find it is predicted that as cat. So likewise, this epoch, it ran 10, but it took some time and we got nearly 0.75. But you can go and make it run furthermore, so the run or accuracy may increase at some point. It may dip it, and then you can stop with that too. Okay, so this is how you will be using a CNN for our neural network for deep learning project. And that's it, guys. Thank you. So with the next class, we'll be seeing about the basics of natural language processing, and we'll be covering another project based on natural language processing, and then we'll be jumping into machine learning operations, the deployment starting with Git and GitHub. Thank you. Thanks for watching.